And you'll remember, probably it's all gone because it's like, what, a week ago. P-Set 4 was mostly about the topic of equivalence. Classes, equivalence in music. What were some of the things that we were talking about back then? Because this is just going to keep coming up all semester. What are some things that we could say in some contexts that two notes or two pitches are different, but in another context we might say they're equivalent to each other? Yeah. Octaves, great. Let's just shoot out. Permutation. Cardinality. Transposition. Inversion. And the one that's not part of the optic spelling. Good. Good. Just while I put some things on the board, shout out some more things we talked about in class that we didn't put on the problem set. What were some other things that we say things are the same, even though they might sound different? Instrumentation, yeah, we suddenly say, hey, that note's a C, and it's like, no, that note was on a piano, and this one was on a trumpet. Good. Other things? And harmonics, yep, that goes with, is a special class of spelling. Good, but it's good to use that term. Anything else? So I said it doesn't matter how long the note is, it's still a C, right? Yeah, so duration when we're talking about notes. Good. So I can't apparently lead a discussion and write things on the board. But I want to talk about two things that came up a lot. One of them I don't need notation for, and one of them I do. One of them is much better. B sharp 4 to, I don't know, it doesn't really matter, but it's F sharp 5. You were asked to write a program to automatically generate the interval you were asked to write a program to automatically generate the interval of anything, and this was one of my hidden test cases that I think it's the only problem that over half, maybe 3/4 of the class, the problem came up with. Which one of these two notes is the problematic one? Take a guess. B sharp, good. Now, B sharp's a problematic note the way E sharp is, right? But it also has its own special problematic things. What's B sharp for? What note does that sound like? C5, good. So the issue that came up a lot is the only thing, what should this interval be? Let's think about that first. What should the interval be? Yeah.
Diminished fifth.
Diminished fifth. So let's think about that. Diminished fifth. Good. Yeah, what would be the interval if it was C5 to F sharp 5? Anybody? Augmented fourth. Good. So the 4 and the 5 are changed around based on the number of distances in the step spacing, which you all did great on. But now we have a different problem. And so what came up a lot from various things, I saw a lot of D, 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 D. Is that the right number? D, 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 12th. I think that might not be enough Ds. Because the issue is that the B sharp is something that sounds in kind of octave 5, but it's not. So always when you're thinking of, how's your screwy prof going to try to screw you up, think about these things that cross over the boundaries between octaves or sound like one thing, not the other. A lot of times what happened was you needed to do something mod 12 at a certain point, add an offset depending on how your algorithm works, and then mod 12 it again. So this sort of double mod 12. At this point, we're going to be working for algorithms that get things right. We can work on efficient algorithms as sort of more efficient ones as kind of a project later. Good. The second one that came up had to do with asking you, this was done by hand, to come up with a pitch set that was equivalent to the one I gave you using P permutation and T transposition, but without octave inversion or cardinality equivalence. And most of you were like, I don't even want to think about inversional equivalence, so that's good. And cardinality equivalence, it just means that I gave you 3 notes. How many notes should you have? 3, good, good. So the hard part, so this was A4, E5, C sharp 4. What I'd like you to do when you have a problem like this is go back to do it the old-fashioned way first. Get out staff paper or use Finale, Musicology, whatever you're using, and try to make sure that you're seeing what the notes are. So where's A4 go? Stop.
2. Stop.
Stop. Okay, good. A4. What's the next one? E5. Stop. Okay, good. Go slower, Prof, right? And then, what's the next one? C sharp 4, right? Stop. What's the common name we would call to this if this were a chord?
A major.
A major?
First inversion.
In first inversion, yeah. So, oops, I got to jostle this, otherwise blood red. Yes, first inversion. Okay. So then what you need to do, you want to do is something that, and it had to use both. Now, I think I tried to say it in such a way that even an MIT student wouldn't be allowed to say, well, you know, not rearranging anything is a permutation, and transposition by perfect unison is a transposition, but you needed to change them in some way. So one of the things you could do, so one of the things that happened a lot was that the octaves got changed. And so that ended up being about 40% of the errors that we saw. So what you can do is you could first repermute things. And probably the repermutation that I would do first is, let's just put it in ascending order. So that's probably the permutation you'd like to have your computer do anyhow. And then let's just shift everything up. One way you could do it, well, in this one, I was going to say shift everything up a space or a line, but the E is the problem. So let's just transpose up a major second. What are we going to get here?
D sharp.
D sharp. B.
F sharp.
F sharp, good. Not because, well, no, this one we had implicitly, because everything on this we had spelling, and that's an S, not a 5, spelling equivalence. So yeah, so D sharp 4, B 4, and F sharp 5. So when you get that back, that's there. Any other questions on problem set 4? Hardest programming problem set so far?
No.
No.
2.
2 was harder for some people. Anyone vote for 1? No, okay. If 1 was the hardest, probably you're not here now. But sorry, I shouldn't say that. Yeah. But yeah, so problem set 6 we'll be announcing today. It is also a slight programming one. It's designed to give you a little bit of a break. And I'll talk about it in a bit, but it's more of a the only sort of participation grade type of problem set than trying to get the exact results. So we're going to have a little bit of a break coming up for things. Somebody want to volunteer? What electronic corpora did you find online? Adam?
Yeah, we did Musicology.
Musicology. Great. What is that?
It's a dual database and search query data corpus.
Cool. Great. Another group. Yeah, Misha.
We did Ultimate Guitar.
Ultimate Guitar. Great. How's that encoded?
I mean, they started off with just like text, ASCII guitar tab, but then they've kind of expanded and incorporated more advanced software.
Oh, cool. Yeah, I remember when it was a lot of ASCII guitar tabs. I think everybody had their own parser for the Ultimate Guitar at some point. Good. Anybody else? Vanessa?
And with the video game music database.
Video game music database. Fantastic. Great repository. What were things mostly encoded for that?
Almost everything was in MIDI files.
Almost everything was in MIDI files. Why do you think that was?
I think it's like generally a standard, and it's relatively small file sizes, so it's easier to like mass pump out a whole bunch of different files.
It is. Also, that's probably how they were encoded in a lot of, especially the early video games. They were encoded so when you're ripping from, or something like that, but definitely not encoding sharps and flats. Good. One last one. Sherry, your group?
Oh, we did a Jazzamat. It was a jazz database.
A jazz database. Fantastic, fantastic. What were the encodings for that?
They had a variety. They had like the transcribed sheet music for a lot of jazz solos, and then also a CSV file. that just had every note's offset from the very beginning and its pitch as a number.
Cool. What you'll find is a lot of these data sets, they really have their own sort of one-off, make-your-own format. Because, like, I don't think that that one's a standard, but I've seen lots of these because that's how things tend to go. Great. We're going to get right back to representation in just a bit. We've a special guest, Michael Good, who knows a little something about representations, being the creator of Music XML and founder, and Britta Bell, also from the Dean's Office. And so if you guys can stick around for 10 minutes, I'd like to, before we do that, let's get sort of warmed up for probably the thing that are on some people's mind, right? The downgraded midterm, which is now, I'm calling it quiz because I'd like to divide this into two smaller, lower stress things. And that will be on Wednesday. We'll start recording about 30, 40 minutes in. I'm designing it to take 30 minutes. If we take a little bit longer, that's okay. It's not all about the rush. But we will do one type of thing that is about sort of recall. So the quiz will be not about your programming skills, but about the reading. And I want the quizzes to be more about the readings so that you keep thinking about ideas that you're going to be doing in your projects. As we keep going with further problem sets, each one of them will start having a little bit of, what do we call it? Sort of assign yourself your own problem and start it. Okay, we got some sound going. We don't really need that, but we can turn that down for a bit. Who's done Kahoot before? Okay, who knew that MIT apparently let their Kahoot subscription lapse sometime between the last time I'm in here? So I'm only able to do 10 players. So can you all pair up and do in teams with the other? I know. I was trying to fill out the subscription form right behind class. So can you team up? 1, 2, 3. 3, 4, 5, 6, 7, 8. Actually, you can be your own team 9. Or do you want to do it with Michael? Stuff. Okay, we might have one more thing to do it. Okay. Oh yeah. Use any nickname you want. Just make it family safe. Oh, you can decide if you want to be. Okay. So this is just to judge how much time you feel like you might need to spend reviewing the things. Okay, we have 1, 2, 3, 4. We have nickname 2. Great. 5, 6. Okay, we'll do a little bit of the background music, but although maybe. Okay, we have 8. Anybody waiting on? 2 more people want to be loners, go on their own? Okay, no, that's good. We're gonna get started. Oh, we got winners, okay. Oh, and okay, great, super. Here we go, so about 20 or 30 seconds on each one. There's 11 questions, I think. 13 questions, maybe. Which of the following is a binary music representation? So this is your time if you haven't done this before. Block in something. No points for wrong. 3, 2. What do we have? MIDI. MIDI is the only one that is typically represented in binary code and not in text. Okay. I know you would have thought I would have made the answer Music XML to honor our guest, but we didn't.
You knew it wasn't Music XML.
You knew it wasn't Music XML because you studied that well enough. Good. Let's keep going. Okay. Hey, the creative nicknames are up top. According to Cook, what is ironic about the timing of the rise and fall of comparative and computational musicology? Hey, mostly we got it. Comparative musicology, which is kind of designed well for computers, declined at the time computers came up. Okay, that's Nicholas Cook's Comparative and Computational Musicology to review, if that one wasn't obvious. We'll keep going. Okay, we got much more on the board. Who was not a composer whose music was discussed by Cook? Who was not in there? This is a hard one. This is about as hard as I'll get. 3 seconds. Oh, most people got it. Wagner. No, Ligeti was the one with all the graphs showing when things come in and out. And the Haydn one, Haydn was used as the example for the German nationalist song. He was the composer of the music, but not the lyrics. Okay, we got one fire. The Music 21 iterator, talking about my own stuff, that returns offsets from the start of the part is one more person. 2 seconds. Hey, almost everybody got flattened. I know, you know that somebody was trying to do the thought experiment that I like recurse better. I keep telling you use recurse, but in this case, flatten is the better one. Oops. Okay. Who wrote about musical codes in the introduction to Beyond MIDI? Oh, nicely done. Nicely done. No. Michael Good does have an article in that book, but no, you don't know. That was the next virtual score.
What I wrote before starting.
Okay. Getting close. Dmitry Chmotko criticized me for all of these things about Music 21, except what? This is hard. And, oh, no, the one thing he didn't criticize me for is the worst feature on it. It is really hard to install, but somehow he already got it installed, so he didn't care about that. Okay. So that was one that shook things up. The snowman. Here we go. We're over halfway there. This is an extra credit from an optional reading, so don't worry, but take a guess on this one. Donald Byrd created his Extremes of Music Notation thing to show that notation what?
It's gotta be red. It's gotta be red.
Yeah, good. Okay, we don't need to discuss that. Even if you didn't do the reading, it's a really cool article if you haven't had a chance to flip through it. Some weird things in there. Craig Sapp's name, good guy, appeared in this class for his creation of what? Okay, what do we get? Yes. The illustration of the same passage of music in dozens of encodings, also known, allowing you to translate from one encoding to another, called the Rosetta Stone. Yep. we got, he now runs the humdrum thing, but it was David Huron here. Nobody did this one, and yeah. I don't know the answer to the red.
Does the yellow exist?
Yes, I believe so, somewhere. This is from the reading for today, so we'll see if we got today's reading. What does David Lewin call his unifying rule for species counterpoint? Okay, a lot of people those who said golden rule, by the way, I am going to misspeak and call it the golden rule a lot because I do that, but yep. We'll talk about it a little bit more at the end of class today. Common or conventional music notation, also CWMN, consists of what? 7 answers. Yeah, I know all of the above is almost always the right answer when you take a guess, but no, in this case, it was just things that traditional Western music notation in some ways, so that you can write down non-Western, and you can encode, as you all know, you can encode many things into the computer that are not that. So great, we're doing well. Now, okay, 3 more. Oh, wow. Nice. We don't need to do that anymore. Arden and Huron showed how European folk song varied across genres, times, locations, functions. Hey, yep, almost always got that. This was the article that showed the geographic information systems back when that was very, very hard to do. We should be able to do this more easily with Google Maps and things. Okay. Before we do the last one, just to know, the quiz will not be a bunch of these little factoid things. That's just all I can figure out to do on Kahoot. It will be actually about conceptual issues and ability to apply these ideas. But let's finish this. Oh, it's about Sophia Sun and me showed connections between music and emotion using what types of musical scores? Oh, no, I know I do too many Bach chorales and I do medieval music, but it was lead sheets. So, yep, oh yeah, you read the, great. So, we have on the podium, 3rd place, nickname 3. Anybody want to claim their podium? Nicely done. Nickname 2, yep, and on top. I guess this shows that some people spend their time not thinking of creative names, but just reading the articles. Congrats, everybody. So we've been talking a lot about encodings, and what you'll be doing over the course of the semester sometimes is working with these strange encodings, and maybe as we're starting to get, well, let me say, you've had some problem sets where I've given you questions and you've given answers, right? And now you've given 2 problem sets, that encoding one and this corpora one, where you've been doing the research to find interesting problems, but I haven't been asking you to actually get an answer. You didn't need to make a parser for guitar, ultimate guitar, in order to answer any questions. as we're getting to the end of the semester, we'll be bringing those two things colliding together and doing more on how you can come up with your own problems and come up with your own solutions. Michael, would you like to come up and talk for just a little bit? I'd like to introduce Michael Good, who's an MIT grad and the inventor of Music XML up here, who's visiting. You all have seen an interview with Michael, right? So just wanted to talk. The interview's a couple years old now. I think we did it during COVID. Yeah. So what's been up and interesting in the world of anything with computer music, but especially music theory, encoding, anything that you've been finding or?
Oh, yeah, that's it. I retired in January, so my mind has sort of gone out of the music notation area.
I'll just stand closer to the mic.
I mean, some of the things that were in these projects were really cool. The body percussion encoding stuff, and it's like, oh, that was pretty great.
Yeah. Do you feel like now you've got to come out of retirement and find a way to put all these things into Music XML?
Not yet.
Okay. So, but
In the future.
But what are some ways that somebody could get a particular musical project if they're interested in non-Western music or something else and get such a standard sort of musical encoding as you've created? What kind of advice would you give for that?
Well, to develop a standard for a music representation, you need to have multiple people who are using it, right? And you need to have, I think, tools that support it. So that becomes, if it's non-standard, that becomes more of a, less common repertoire. That becomes more of a chicken and an egg problem. So look for something that has at least 2 applications that are doing that type of music, and see if you can do, maybe one's an application you wrote and one's an application somebody else wrote, and try to put something in between. I mean, when I was starting Music XML, a lot of people had tried to do a standard common Western music notation format, and I knew that if it didn't work with either Finale or Sibelius, because those are the 2 programs people cared about then, if it didn't work with at least one of those 2 programs, I was just going to give up, go home, and find something else to do, because nobody would care about Music XML if it didn't work with one of those programs. Nowadays, it would be Musicology or Dorco or things like that. So if you're trying to do a standard music representation, then you need to have a community of people who are using it and applications that use it. Maybe more interesting is just to, at this point, is to come up with cool things that could be represented and do some analysis there and try to figure out ways that these representations could be useful for the musicians who are doing these type of repertoires.
Great. So Michael, you did music when you were at MIT?
Oh, yeah.
What kinds of things did you do?
Well, I was a trumpet player. Nowadays I sing. My wife and I met in the MIT concert band.
She's an electrical engineer, right?
Yeah, she's one of the 40 top engineers at Analog Devices. So she just was talking with Ray State at her company conference a couple days ago. So she's 6'1", I'm 6'3". I'm class of 79, she's class of 82, and she played piccolo, I played trumpet, and I played trumpet in the band, the orchestra, festival jazz ensemble, chamber music society, musical theater, anything that needed a trumpet.
Laptop ensemble?
I played it. There was
no laptop.
Laptops were not invented. I was using the coolest thing. I did my thesis in the experimental music studio with Professor Barry Furco,
which is now the Media Lab.
One of the groups that became part of the Media Lab. And the coolest thing was we got to use VT52 terminals instead, video terminals instead of the paper terminals that I was using for all my other classes. So I got to use the coolest computer technology that I'd seen at that point in my computer music class. So that was awesome.
So Michael, here's a question I don't think I've ever asked you. So you did music while you were at MIT, and you did other things, and then but music wasn't your primary sort of putting money in a bank for a bit. You can ask a little bit about what that was, but what made you want to come back and do it? And is there anything for anybody who's not thinking of graduating this year, next year, or whatever, and doing music, but might follow a career like yours?
Well, yeah, following a career like mine is kind of, I mean, it's a whole different time now. When I was doing my bachelor's thesis at the experimental music studio, it was on one of these alphanumeric encodings which is now called Scott. It's actually still shipped, I think, as part of C Sound. And I was rewriting it from an earlier version called Sogo, but this was in 1979, so there was no MIDI, right? There was no computer music technology industry. Okay, New England Digital was doing some claviers, but that was one tiny company. So there wasn't any industry to go to for a job, so I started to do usability work as for my grad school. I got my master's here too. And I did usability work until 2000 when you could see that everything was going to, this is when the web was coming up, and everything was going to be move this app over to the web from a GUI. And the first time I did that, it was a lot of fun, but doing it 1,000 times was going to be really boring. So I looked at, there was an opportunity to do a standard music notation format. There was downloadable sheet music starting to happen. It was a nascent thing. So there was obviously a demand for a standard computer music because it was silly. You could download the music and all you could do was use it in the player or print it out. And it's like, you should be able to share it back and forth between programs like HTML and MIDI. If you don't have a standard, it's nothing for that type of common thing. So that was the motivation to do it, that I wanted to use downloadable music in any application. But I had the financial ability to do that because my wife worked for Analog Devices as an electrical engineer, and their company did really well. And so if I totally failed, it didn't matter financially. So, I was in an extremely lucky position there. Nowadays, though, you could, you got each other all interested in music technology, and there's all sorts, to go through, if I had had a class like this, I wouldn't have had a class like this because I had to spend all my time building infrastructure. Now you can do the cool things on top of the cool problems on top of it. So find cool problems that people are interested in. If you want to make a career, if you're just studying, find a cool problem that you're interested in. Well, that's, I guess, the starting point anyway. Find a cool problem that you're interested in, because if you're not interested in it, you won't be able to make a living at it. You'll just be terribly bored. And then find if somebody else is interested in that or something adjacent.
One last question before I let you go, if that's okay. It's hard for us to think of, that you went from the essentially teletype era, things, you don't see things on screen, you have to type it onto it, and then it all comes out on paper and stuff in 30 bytes per second modems and things like that, to, until 2 months ago when you retired, you were still totally on top of like 99%, as many percent of the new technologies as anybody can do and things. And someday it's hard for us to think, but these will seem as outrageous as a teletype or a horse and buggy and stuff. Not just for music people, but how do we keep up? How do we keep up like you with all the changing technology?
If you're a tech person, I think you kind of do that. Because I live in Silicon Valley, you gotta stay with what's going. I have this usability background, so I was always interested in the user interface technologies. But I don't know anything about machine learning or outside of applications for it. In the music space, I'm excited to see what Sound Slice is doing for using machine learning for optical music recognition, what Audio Shake is doing for source separation of audio, which everybody tried to do, and they're the first ones who are able to do it, and they're very clear about which problems they can handle and which problems they can't, and why it's a good market and why it's supporting musicians. So
we were talking just a little bit earlier about with generative music things, sort of to sum up what you're saying is make sure that there's a problem that you're trying to solve.
Yeah, a problem that you're trying to solve that isn't putting musicians out of work would be
Right. Well, thanks, Michael. I wish we could have had you earlier when we were specifically talking music XML, but you can't go 6 weeks into the semester without knowing music XML. So even knowing you're coming now, it's so great. So thanks.
Okay.
And feel free to stay, feel free to move on. We're going to unlock intervals. We're going to be moving on to the shortest topic of the semester, and that is voice leading. You're going to get just a little bit from me today. You're going to have the world's shortest not the world's shortest, but a pretty short problem set. And then we'll talk about it a little bit after the midterm on Wednesday, and that will be it. It's a very important topic. We're going to keep working on it. That's why it deserves to have its own number. When we're talking about voice leading, we're generally talking about how, we just need one staff for this, how multiple parts are moving at the same time. So this would be pretty bad voice leading, maybe very dissonant, but something. We're talking about not what's happening here and not what's happening, oh, that one's hard to do, here, but the combination of the two. And why voice leading becomes a particularly interesting problem for computers is there's two general ways of iterating. Both flatten and recurse are in some ways, well, no, sorry, recurse is sort of you go through one part or one voice and you go through everything, and you go through the other part and the other voice and you go through everything. And then you have something like flatten, which in the end, especially if everything is just quarter notes, you're going through one slice, going to the next, and going to the next slice. So voice leading is a particular problem that requires you to be constantly moving back and forth between I'm moving according to voice or according to part, and I'm looking at what's happening at one time or another. One of the classic applications for sort of starting off computational voice leading is to work on a topic called species counterpoint. Has anybody who has done species counterpoint in one of their classes? Some instructors do it, some don't. Not everybody has. So I think it's an 18th century way of learning to write music like they wrote it in the 16th century. So not 100% relevant to music composition today, but still sort of a fundamental skill like you practicing your scales or something. Mozart and Brahms practiced species counterpoint every day, sort of keep up their chops. The first species that we tend to call it is something is all in whole notes. Let me see if I can compose one while we're. How many notes do I write? 1, 2, 3, 4, 5, 6, 7, 8, 9. Good. Classic ones tend to be around 9 notes long. And then against this, in first species, you're going to write one whole note for every note with particular conditions. And some of these conditions will be horizontally constraining. Like, for instance, now that particular one. Don't do that. Why not? Tritone, yep. This case, augmented fourth or diminished fifth, usually not allowed also, especially in this context. Good. So some of these things are going to be based on that, on one case, and some of them are going to be based on vertical things. This would not be allowed. Why not? Sorry, I need two colors. What? Somebody said it. I just didn't hear. No, I think I heard it properly. So, seventh, yeah. So in first species, the rule is all horizontal vertical intervals must be consonant, and all vertical intervals must be consonant. But then there are other strange little rules, like this is a consonant interval, this is a consonant interval, and this is a consonant. I said I was going to do red. This is a consonant interval. All these intervals are consonant. What's the problem here with these two? For anybody who's done this. Yeah, so parallel fifths. So what's the interval G to D? Perfect fifth. E to B, perfect fifth. So two perfect fifths in a row. So I just want to give for anybody who wants to, I don't have a formalized extra credit for this, but if you can, writing software that can solve any given, what we call this is the part that's given to you. There's always one part that's given to you. It's called the cantus firmus, or the fixed song in Latin. And so you fixed, you can't change it. And one of the classic things is to write, nowadays in computers, is to write software that can solve the other part, that can give you the other part there. And that's one of the ones, if you're interested in optimization and algorithmic things, that this is one of the cases, the first cases in this class, where it is easy to write something that will do it properly, but for a 20-note or 40-note one won't be able to generate it in the time that the universe, before the heat death of the universe. So it's something where algorithmic complexity comes in. You are not going to be given that assignment this year. You all have worked pretty hard, right? This class is, yeah, okay. So not doing that seems like a good thing. But instead, what you're going to be asked to do over between now and next Friday is to come up and encode some of the basic features underlying how you might solve a problem like this, and specifically how you might avoid things like this. There's one or two things on this. This is not, again, an everything correct problem set, but looking quite down the road to the second, probably the second to last problem set in this class, problem set 9, this will be foundational knowledge on it. And that one, problem set 9, you're going to be given a piece and you're going to be asked to remove all the passing tones and all the ornaments and leave it just with the block chords. And so being able to identify voice leading moments is pretty important. Okay, so let's unlock intervals. You've been working a lot on them. So unlocking interval. Let's go ahead and, from Music 21, import corpus, which we'll use just at the very end if we have time, note, pitch, and the brand new interval module. Is that big enough? Bigger, better? Okay. We'll start with the worst variable name ever. I equals the interval module, so it's lowercase, and the interval class in there, P5. Let's start with a perfect fifth. These are all things that you've been doing. Within the interval module, by the way, there are interval classes called chromatic interval, diatonic interval, generic interval, all these things. But the interval class will let you do basically almost anything in there. Great. So now you've created a P5 interval. You can get its name, which is very unhelpful. It just tells you what you just put in. But you can get its nice name with a capital N in the middle. Perfect fifth. So it's just a little bit more helpful. Let's keep going. We can get its directed nice name. So this is all in snake case or camel case, whatever you want to call it. Directed nice with a capital N, name with a capital M, and get ascending perfect fifth. So there's sometimes we care about what direction the interval is, and sometimes we don't. In melodies, we care or don't care. Take a guess. When you're talking about melodies, do we care which direction the interval is? Yes. When we're talking about the notes of a chord, do we care? No, not usually, right? Because we're just talking about what things are. Great. So if we want to create a descending interval, we can create interval.interval p -5 and get its directed nice name. You don't have to type all these things. I'll put this up later if you're not a fast typist, but you can do that. Also, because I can never remember which one we prefer, you can do -P5 because I don't know which one of those is actually better. Okay, so that's the most basic way of doing things. Let's try to get the intervals from pitches. First off, so let's create two pitches. We'll create pitch.pitch B3 P2 pitch dot pitch C5. So not a little hard, but not too hard. And you don't need to type the question marks. We're going to get the interval between P1 and P2. So you can, instead of putting in a string, you can give it 2 pitches or something. And I'm going to name this variable after what the name should be. The interval between B3 and C5, what should I call that? Somebody who hasn't already gotten ahead in the computer. What is that interval? Always try to do things in your head the first time. Minor ninth. So I'll do lowercase m, 9. I do like naming things according to their interval or according to what they're representing. It does hit my anal retentive, everything must be an order streak, that when we do have something that should be a major third, and it's capital M, but then I go capital should only be used for classes, and but sometimes we have to do that. Okay, so we have, do we get that? Yep. Minor ninth, how many semitones in a minor ninth?
13.
13. So dot semitones will give you the number of semitones in an interval, which is often quite helpful. Obviously, m9.name will give you m9, but m9.simplename, also in snake case. So when you're dealing with compound intervals, there is something called simple name that will be very helpful for working through things. There's some slight difference. Let's come up with another interval. This one I'll call P8, and I'll just show so you can do some of these things here. We can also create an interval from notes, not just from pitches. That's probably a mistake in my taxonomy, moronomy, whatever it is, but it's been there for a while. So P8 should be C4 to C5. Good. The only difference why I'm creating octave, I should have just called it octave, right, is that sometimes that the octave simple name is perfect unison, P1, right? But sometimes we care about the difference between octaves and unisons in a way that we don't care about seconds and ninths. So there is something called P8.semi-simple name. I wish I had spent some more time coming up with it, which basically is exactly the same as a simple name, except that things that are multiples of octaves get squished down to an octave. So a double octave also becomes an octave in the semi-simple name, whereas the ninth's semi-simple name is minor second. And I think there's also things, see if I still have all these in here, semi-simple, nice name. Yeah, okay, so there are all of these things in there. Great. Let's stop typing so much and let's create some aliases. Alias, what's this? Capital I is the interval.interval class. So now we can call I and get a new interval, and P equals the pitch.pitch class. Not a pitch class, the class pitch inside the module pitch. Right. Is that able to be seen? Great. So now we can create like minor third, just like that, just a capital I, parentheses, and slow down. Okay. Slow down. Slow down. Yes, a little bit. Okay. Good. Great. Pause for a second on this. So far this is great, except for being able to get the interval from 2 pitches, which will probably be very helpful for you. There's not too much you can do once you have an interval object. So let's start creating some things that, so don't have to type all these things, but this is probably a nice one to do. The interval of a minor third is consonant. Now, this is probably a mistaken term before I hit enter, because all of these things are consonant in some of the world's traditions, and not in some of the other world's traditions. In fact, some of the early proposals of Music 21 said, oh, and then you'll be able to have a context object which will be able to affect how these things are. So if you're in 14th century Europe, this will be false, and if you're in some part, if you're giving it a southern Indian context, it might be falser, depending on what the time is. And I've never actually fully implemented that. So right now, unfortunately, this privileges the Western sort of classical music context. What should this be if it's in a Western classical music context? Minor thirds are consonant or dissonant?
Consonant.
Consonant. Whew. Good, I programmed something right. Now, let's try something else. A major sixth, consonant or dissonant?
Consonant.
Consonant, good. And sorry, I'm typing a lot here. You can probably assign things variables. The number of semitones in a major sixth?
9.
9, good. Now I'm going to create a diminished seventh. I, lowercase d, 7. And number of semitones in a diminished seventh?
11.
Can I get one guess? Another guess?
9.
9. So diminished seventh is consonant? False. So one of the things built into the Music 21 ontology that's different from Dmitry Chmachko's optic default ontology is that spelling matters in this case. So diminished seventh sounds the same as a major sixth in isolation, but it's not considered consonant. That's important to know, and I think last year there was a month that went by without somebody reporting this as a bug to the Music 21 list. But most months, 1 to 2 people put that in, not see that. So it definitely means that I don't know, an augmented seventh is not consonant either, even though an augmented seventh is another way of saying octave, perfect octave, great, super. Basically, anything in traditional theory, in traditional tonal theory, anything that is marked as diminished or augmented or doubly diminished or doubly augmented or whatever is considered dissonant. Now, the weird one that we can always debate is the perfect fourth. Who thinks it's consonants? Who thinks it's a dissonance? A lot of people not voting. I'm glad for either way people voted. In this case, Music 21 regards it as not a consonant. Perfect fourths are generally, they're the one weird interval. They're generally considered consonant when they are melodic, but dissonant when they're harmonic and above the bass. So it's take medieval music with me or Spiro. You can figure out the whole history of how this happened and why it's in the one weird double position. But it's the only perfect thing that is not consonant in some circumstances. Okay. What are some of the things you might do in interval class? Well, let's start with, let's create the perfect fifth one, P5. Hopefully I've created that. Good. And what we can do is, let's say C4, we'll just call this, equals P C4. And now P5 can transpose pitch C4. So you have a perfect fifth, creating that as an interval object, storing as P5. We can create a pitch object. These just because of my aliases, C4, store at C4. Then P5 can transpose the C4, transpose pitch on C4, and gets a pitch object that's G4. Now, once you've done that, if we look at C4, that object is unchanged. So transpose pitch creates a new pitch that is not the same pitch. So if you wanted to do something useful with this, you would probably store it as G4 equals this. And then you can do something with your new pitch. Obviously, if you knew what the pitch was going to be coming in and what the pitch was going to be coming out, you wouldn't need to do this, right? You can just create your own damn G4. But this would work sort of in general. If you do want to transpose in place, I don't think we've seen this in Music 21, but you're going to start seeing it all over the place. There is a keyword-only argument. That means you must type this as a keyword. In place equals true, so C4 will now be transposed, and nothing will be returned. We run it, but now C4 is a really terribly named variable, right? Because C4 is now a G4. If you're ever doing a demo, you'll remember when we took 2 notes, we inserted 2 notes or we moved them from the stream and then everything was screwed up. So I'm going to learn from that experience and make C4 equal C4 right again. But sometimes we want to just have a generic P equals, here. This time I'll write it out so that we can copy and paste this. Pitch.pitch C4. And we still have P5. Let's just do this. For I in range 13, we don't actually need I. Some people like to have underscore as a dummy variable. But we're just going to, for 13 times, let's take the pitch. And then we can, since we just done it, P5 transpose pitch P in place equals true. So we create a C4 13 times. We're going to go through and transpose it. So what is P now?
C11.
B sharp.
B sharp.
B sharp 10. Is that what it is? Oops, not C. What do you call it? P? F double sharp 11. Because if you notice, we were printing and then transposing. It was a little trick thing just to make sure that we're all following things. Yeah. So by the way, this is one of the weird reasons why I wanted you to work early on with weird octave numbers like 10 and 11 and -2 and things like that, because quite often it is simpler to do an operation like this, like let's all go around the circle of fifths and then we'll just print the step of it and not care about the octave number. And then in the end, we can bring it back down a bunch of octaves later. But sometimes you're going to end up in there, and sometimes you're going to end up in double sharp territory, triple sharp territory, before then transposing down back the other way or doing some other path. So almost never is F quadruple sharp 22 going to be a useful thing to think about musically. But sometimes it's a useful point in the midpoint of your work. And by the way, that's how imaginary numbers came out first, that they were first used to solve, I believe, quintic equations in a way that made it very easy, even though they were in the intermediate stages, even though they were never the answer at the end. So think of quadruple sharps and octave 22s and stuff as like that. Okay, so a couple things. Is C4 still C4? Yep, good. You can also transpose, do the opposite way, and this is a real something that Python allows that other languages I haven't been able to do it in. So instead of taking the interval and saying dot transpose pitch in the pitch, you can take the pitch and say transpose that by the interval, and that's sometimes pretty helpful. So Music 21 object dot transpose by an interval class, and if you don't care about efficiency, you can always put in just a string, and it will create an interval for you. And so transposing up an augmented 223rd gets you G sharp 35. Is that right? Doesn't matter. Okay. By the way, okay. Looking at the time, one or two last things. If you ever want something when you're working with this is the interval object again, perfect fifth. There are things like specifier in here, and you'll be able to you know how to do dir on a, what do you call it, on a object to see everything that's in it. But these are probably the most useful things you'll see. So how many cents, how many hundredths of a semitone is it? And yes, you can do microtonal intervals if you care about such things. What's the chromatic interval? What's the complement? If you have a major sixth, the complement is a, remember it's minor third. It's the thing that fills out the octave. Diatonic, is it a skip? Is it a step? Can we reverse the interval? All these things. So you'll find some of these things in here. But the last thing I want to do is to think about this spelling, non-spelling thing. So implicit diatonic, we'll say. Let's create the interval of 4 semitones. So all I care is that it's an interval of 4 semitones. And here's where, what do we call it? Polyvalent, polygamous, whatever we call the interval. It will take, that was a joke. It will take an integer instead of a string. So we can say the int 4. And if I just look at this I4 right now, it looks like, hey, it's just a cheap way of saying major third. But it's actually a little bit different from that. So if I take the pitch C double flat, so pitch C double flat 4, and I'd say I4 transpose that pitch. So take C double flat 4 and take it up a major third. I don't care about the accidental, but what's the step have to be if you're going up a third from C something?
E.
E. So it should be, what is that? E double flat 4. And instead, you get a D4. So there's something where if you initiate an interval just by saying the number of semitones, you're telling that interval that the diatonic interval, the major third, is implicit. That is to say, when you want to know if it's a major third, yeah, it'll be a major third. But I4 will say, no, feel free to change this to anything that is 4 semitones up that is logical and easy to use. So that's something that people will see in there. Whereas if we take the perfect fifth and see, which we created it with the P5 thing, and see if it's an implicit diatonic, false. Perfect fifth will always take the one that we created with the string P5, will always make sure that something is a P5. I'm looking at the time, so I won't demonstrate. The last thing, which is Music 21 still has a restriction that it won't go above quadruple sharps or quadruple flats. So at that point, even the diatonic one will say, forget what I said. Let's make it work and round things. Great. That's all the time that I have. If you transpose a whole score, you'll see that the key signature is transposed with you, which can be kind of helpful. And I'll post my what do you call it? The thing where I have that demo to the class.